Peter here from team 7407. So this is our hatch panel intake and extake, or mechanism. So basically how it works is we put 3 main pieces of Velcro onto a wood cutout to grasp the hatch panel when taking it off the brushes from the human loader and putting it back onto the cargo ship or the rocket ship. We put them in specific places to avoid contact with the brushes when getting the actual hatch panel from the human loader. And then the other main component is that we made a cutout in the back area so that when our conveyor belt for the cargo shoots out the ball, the ball can actually pass through without interfering with the actual mechanism. And then also on the back we put 3 pneumatic cylinders to extape the hatch panel from the Velcro initially.
Hi, I'm Parth. I've also been working on the hatch panel mechanism a lot. And so another potential hatch panel mechanism we've designed is this Y right here. So it's essentially the same type of wood cutout with Velcro, 3 Velcro pieces attached in specific points to avoid the brushes. And then we'll also, if we use this mechanism, we'll attach the pneumatic cylinders at the back. Something special about this design is that it's able to come out like this and come back together with the rubber bands we've attached here. We'll probably use some sort of constant force spring if we use it on our actual robot, but what this will allow is the spacing with our cargo shooter. It's a little tight, so if we need the cargo shooter to come down a bit more, then we'll be able to spread the hatch panel mechanism like this to allow for that room.
Well, I am working on our cargo intake and extake for the robot. So basically what we have is a conveyor belt that goes from the back of the robot, intakes it, and then brings it to the top and is able to extake it at the low levels of the rocket ship and also then the cargo ship. We're also going to have just an external extake that has rollers on it and flips down, like in a lot of the 2016 games, so we can intake balls easier. For the conveyor belt itself, we're going to be using just a conveyor on top and then 2 rails on the bottom to center the ball. Well, we originally wanted the entire conveyor thing to move up and down, but we're running into some issues with intaking the ball into that, and also different heights with our hatch panel mechanism on the front. It would interfere. I mean, on the front, we're planning on using a mechanism roller intake so we can make it wider and it'll center the ball. Oh, and then on the extake at the top, we're planning, instead of having a moving tube, we're planning on just making a moving sort of flywheel mechanism at the back, at the top for the extake of the ball. So we're able to slightly angle it up to get into the cargo chip, and then slightly angle it down to get it to the rocket ship.
Hi guys, so we're the wheelbase team. And to talk about what we did so far, for the first week we built the wheelbase, and the only changes that we made from the original, which is the
AM14U4.
Yep, we changed it by having the open front, and we also replaced the churro on the front with this cross brace to add more sturdiness because of the open front.
Yeah, and also because we wanted to use these Omni Wheels, we had to change the spacing, so that involved putting a washer here and then cutting our own custom spacers to accommodate the Omni Wheel.
And the next thing we did was we worked on the bumpers. So
we cut the fabric. We decided not to sew, but rather cut, and we came up with a way, Jamie especially did a good job of that, being able to tuck it into the corner nicely.
Yep, and I think the most difficult thing with the bumpers was the spacing to mount it onto the wheelbase. So we found that it was easier to put the fabric on first to the plywood and then put the spacing, the braces on.
So for the past week, we've been testing out pneumatics. We've been laying out where the pneumatics would go on this bot and for the electronics. But for the other bot, we've been testing out the pneumatics specifically. So we've been connecting stuff like the pneumatics controller and connecting that from the PDP to the pneumatics controller to the different solenoids that will control how much air goes into the air cylinders. The solenoids determine how much that goes through. So we've been testing it, and we've noticed that, you know, as long as we make sure we have tight connections, we can get the air cylinders to pump through, and we can get part moving. As for the electronics, we've been setting up a layout here, mimicking how we can do connections on other robots. So far we'll have all the stuff that needs to be accessible during a competition on the top. As for other things like motor controllers that look like this stuff will go on the bottom where it can be more easily wired to the motors. As for other mechanisms that require electronics, we'll be keeping that more below because those don't need to be so accessible. That is pretty much it. Other than that, we've been trying to find another place to put the battery in. So trying to fit this behemoth of a thing on the robot.
That thing is a good 10 to 15 pounds, by the way.
And Xavier will talk a little bit about his crimping work.
Well, it may not sound exciting, but that's because it's not. But it's very important. Nonetheless, it's very important because all the wires that are on these things need to have these little metal things as are in this bag. If I can grab one. These little metal things. They need to have these little metal things squished around, like basically you peel off the rubber, squish these little metal things around it with these little flaps, and then with this big thing, and then you gotta somehow figure out a way to stuff them in this, which takes quite a while to actually do. Because it's a nightmare and they don't want to go in.
And the importance of this is that sometimes FRC will give us wires where they're not automatically able to connect to certain ports. So like Xavier is saying, these crimpers are very important to connect to those ports. The motor controllers are one example. Another example is for the battery. Typically FRC does not give us a good connection straight to the battery. So we have to connect these kind of ports as well as these kind of terminals to make sure that we can determine the right length to make the electronics.